Hi, so we're going to have a look at calculating the perimeter of shapes. Just now you maybe seen the first video that I did, and a wee reminder that the perimeter of a shape, as it says in the top corner, is basically the distance all the way around the outside. So what we're looking to do is to highlight the fact that in any shape, if you start at one corner, say for instance, one vertex, if you were to consider the distance all the way around the outside, then that's the perimeter. Not to be confused with area, which is the space in the middle, and eternally people get mixed up with the two ideas. So perimeter is all the way around the outside. Now where there's straight edges that a shape has, we generally, all we need to do is to find the distances or the length of each side and we add them all up. And so we're going to have a look at a few shapes like that just now. So the interesting thing about these diagrams is these are both triangles, and it says calculate the perimeter of the triangle. So fair enough, we want to work out the distance all the way around. The only problem is neither of them give us enough information, because this first triangle on the left only has one side marked and the triangle on the right only has two sides marked, and we need in each case three numbers. So how on earth do we know the distances on the other sides? Well, the key to this, and you may or may not have seen this before, is in these little things here. So if you have a look on any shape, and this is a really important thing to learn when we're looking at shapes, is that if you see a line, a side that's got a line through it, now you might have one, or you might find sometimes it's got two, so it might look like that. In actual fact, they started off with two because they actually are meant to be equal signs. It started off as being two dashes, meaning these three sides are equal. I know over time we started off, rather than always using two, we started off just, well, let's just draw one line. So what started off with an equal sign just became a dash. But you still see some double dash lines, and we'll maybe look at that another time. So what I'm trying to say is that when we see these little dashes on our lines, it means that any line with the same dash is equal in length. So in this triangle here on the left, all three lines have a dash, which means that all three lines are actually 12 centimeters. So I can go ahead and I can write in here, well, that's 12 centimeters. Oops, that's a wee bit scrappy. Shall we rub that out? Oops, where's my rubber gone? There we go. I'll get rid of that. Okay. So what have we got? We've got 12 centimeters here, and down at the bottom we've also got 12 centimeters. And interestingly, again, you may know the answer to this. What's the name that we give to a triangle where all three sides are equal? Do you know? It's called an equilateral triangle. Because equi meaning equal, lateral is Latin for meaning to do with lines, so equal lines. So we can go ahead and calculate the perimeter, which is the whole point of what we were trying to do. So underneath, or you could do it to the side, I want to see the word perimeter written out. Perimeter equals, and we've got three sides here, so you could write down 12, add 12, add 12, and you could do that maybe in your head, or you could do a column addition, and the answer is 36. Well, the number's 36, the answer's not 36. Our units are centimetres, and so we can go ahead and say the perimeter is 36 centimetres. There's another way of doing it. I'll just quickly write that out, because you may have thought, hang on, there's another way. We could say in this case, although we normally add the sides together, there's absolutely no reason why we couldn't explain our working that the perimeter is actually 12 multiplied by 3, because there's 3 lots of 12, which again gives us the same answer. So both of those, in this situation where there's a repeated side many times, it's absolutely fine to suggest that it's a multiplication calculation could help us get the answer or explain what to do. So either of those, you don't have to do them both. Okay, let's look at the right hand side one, because we've got two sides we know and we don't know the third. Well, if on closer inspection, you'll notice that we have these little dashes on two sides, which means that those two sides are the same. In other words, we can say that the top sloping side here is also 6.3 meters. So it's good when you see those dashes in your diagram. I would like you to write in what the matching length is, as I've been doing. You notice that there's not a dash on the third line because it is different, and sure enough we've been told that it's 4.7. So we can calculate the perimeter by writing out the word perimeter equals. Now this time we have to be careful, we can't use a multiplication because it's not one repeated number. So the perimeter, depending on where you start, if you start at the top, it's 6.3, that's along there, and then I go down another 6.3, and then I go up to get back up to the top, that's 4.7. You might be able to do that in your head, or absolutely fine to do a little calculation. Okay, so decimal calculation, so what your decimal point should be in your answer underneath the decimal points. 3 add 3 is 6, and 6 add 7 is 13. So put down the 3 units, carry the 110, and then we've got 1 and 4 is 5, and 6 11, and 7 is 17. Sorry. So there we've got 17.3. 17.3 again. What does that mean? Units are in meters. 17.3 meters is a perimeter. Okay. What's the name that we give to that triangle? Do you know? Where there's two equal sides, you might know it as an isosceles triangle. That comes from the Greek this time. Isos again means equal, a bit like equi in Latin, and skelos is actually the name for a leg in Greek. So it's kind of equal leg, as though somehow leg's just another name for a line in that case. So isosceles, it's good. Here's another couple of questions to take us on a little bit. Let's have a look at, oops, that's kind of gone out of the edge of the page. Let's bring that in. So we'll just get, we'll shove that in just to remind ourselves. Okay, so calculate the perimeter of these shapes here. We've got a regular hexagon, now a regular heptagon. Now, the important thing here is the use of the word regular, because you can have a seven-sided shape with all sorts of different lengths. But in this case, because it's regular, it's another way of saying, well, I can't be bothered writing down all these wee dashes, but I could. You could see a diagram that's got one of them on every side. It makes it look a bit like a porcupine. And that would be fine, but if you're told that the shape is regular, then it does the same job, okay? Regular just means all the sides are the same, okay? So as soon as you see the word regular, then we can assume that whatever we know of one side has to be the same with all the others. So what I can do is I can go ahead and write in all of these 15, 15, 15. Reminds me, how many 15s have I got altogether? 1, 2, 3, 4, 5, 6, 7, because it's a seven-sided shape. So what's the perimeter? Well, again, there's two ways of doing it. If you remember what we did with the triangle, the equilateral triangle, which is a regular triangle. The perimeter, we can either say is 15 plus 15 plus 15 plus 15. You can see that's going to take an awful lot of time and maybe a wee bit complicated. So I'm going to jump straight to the second option. Remember that we said that we could actually just make it into a multiplication. So there's 7 lots of 15, and so we can just say that's the perimeter there. Doesn't mean you won't have a calculation to do. So 15 multiplied by 7, 7 5s are 35, and 7 1s are 7 plus the 3 is 10. So my answer is 105 centimeters. Okay. So any regular shape we can turn into a multiplication. If you want to just add all the numbers all the time, that's absolutely fine too. And the last one here is it's a kind of it's a kind of slightly odd shape here in the sense of it's like a box, an L-shaped block. Okay, so the normal rules apply. We can find the distance all the way around. So let's just take a walk round because this is one that causes a little bit of problems. Let's start at the top here. Now, if I go along here, I've got 8 centimeters. That's good. I've got another line down here, and I don't know the length of that. I've got a line along here that I don't know the length of. I've got a 7 centimeter line. I've got a 14 centimeter line, and then I've got a 16. So all in all, I've got 1, 2, 3, 4, 5, 6 sides. So I need 6 numbers, but I only have 4. Does that mean that I can't solve this problem? Well, actually, we can. And you might have already figured it out because we can work out the missing sides by comparing, in this the case of the top and the bottom. So let's have a look at the bottom of the shape. We can see that all the way along the bottom is 14 centimeters. Let's change the color. 14 centimeters all the way along the bottom. Now, if I take this side here, which is 8, and this side here, which is unknown, those two lines have to be the same length as the one at the bottom. Okay? In other words, that line here and that line here, do you see what I've got here? This line and this line have to add up to 14. So if we know one part is 8, the other part has to be add up with 8 to get 14, or 14 subtract 8, which is 6. And so we can actually write in that this is 6 centimeters. You understand why? Because 8 and 6 makes 14. The long line at the bottom is exactly the same length as the two up top because we're dealing with kind of a shape with right angles. Okay, so there's 6 centimeters there. And we can do the same thing with the vertical lines by looking at the total length. So let's have a look at that left-hand side. I've got, we're going to just go a colour crazy here. So we've got 16 centimeters all the way up and down. And if you look at the way that that height is split up into 2 on the right, we've got this bit here that we don't know, and this bit here that we do know, which is 7. And we know that the unknown bit plus the 7 bit has to be the same as 16. What do you add to 7 to make 16? Well, that would be 9. So we can say that that side there is 9 centimeters. Your diagram won't be quite so full of colour, okay? But now we've got all 6 sides. So I can go ahead and write out the perimeter. Perimeter equals, okay? So what have we got? If we start at the top, I've got 8 plus 9. Going round, I've got 6 and 7 and 14 and 16. Quite a lot to add up there. I notice that 14 and 16 make a nice 30, so I'm going to add them together. 6 and 7, I'm just doing this mentally. You could do it like that too. Let's see, so we've got 30 there, we've got 13 there, and we've got 17 there, between 8 and 9. So 17 and 13 add up to 30, add another 30, gives us 60. But you could have done a column addition or something, but you can use mental strategies as well. So we've got 60 centimeters is our perimeter. Always make sure that you've got as many numbers to add together as you have sides, otherwise you'll make a mistake. Okay, 4 examples there. Hopefully that's helpful. You can go on and practice some of the perimeter questions that I've given you. Okay.